Welcome to this lecture. In the last lecture, we were discussing about the MC/DC testing. We said that it is a very important test criterion. It is practical and also it gives a thorough testing and therefore very popular. Now, let us proceed with what we were discussing last time. We had seen the basic definitions of the MC/DC testing and we had seen few examples about how to develop MC/DC test cases given a conditional statement. But remember that there may be several conditional statements in a program and of course, we need to design for every conditional statement. Now, let us look at a more systematic way to develop the MC/DC test cases. One thing need to mention that here if a conditional expression has n sub expressions, here we have 5 sub expressions 1, 2, 3, 4, 5, then for multiple condition coverage MCC we need 2 to the power 5 which is 32, but for MC/DC test cases it will be just 6, 5 plus 1 is 6, and if there are 10 basic conditions or sub expressions, then for multiple condition coverage we need 2 to the power 10 which is 1024 test cases, but for MC/DC testing we need 11 test cases. We will not give any proof for n plus 1 test cases required for n basic conditions, we will just state this result. Now, let us look at this example expression and see how we go about creating the MC/DC test cases. The first step of course, is to draw the truth table as the different sub expressions or the basic conditions change their truth values. All possible combinations of truth value we need to explore, but that will be 2 to the power 5 which is 32 rows in the truth table, but this screen is small. I just drawn only the important ones. I have not included all the possible combinations. I have omitted the ones which are not required for inclusion in the MC/DC test suite. Once we draw the complete truth table, that is all possible combinations of the truth values of the basic conditions and the corresponding outcome, we need to check for every basic condition which are the 2 rows where the truth value of the basic expression is true and false, and the output also toggles true and false, and the remaining conditions, basic conditions have the same value. Just see here false, true, false, true, and for this also false, true, false, true. So, the other conditions, truth value of other conditions remaining constant, a change of the truth value of the condition under consideration as it toggles from true to false, the outcome toggles from true to false. Similarly, let us look at the second clause. We check all rows and see that when it is false the outcome is true, but when it is true here the outcome is still true. So, these two cannot be the ones. We just check all possible combinations here, and then we find that the second one along with the 13th one, as they change from true to false, as the condition b less than 50 changes from true to false, and the other ones remaining constant, true, false, true, okay, false, true, and this is false, true, false, true. As b less than 50 toggles from true to false, the outcome toggles from true to false. So, we need 113 to show the independent evaluation of the first condition, basic condition. So, this shows the independent, this first condition independently toggles the outcome when the others are remaining constant. Similarly, 2 and 13 toggles the outcome when the rest are held constant. Similarly, the third one, as it toggles from true to false, the outcome toggles from true to false, the other things remaining constant. Similarly, the fourth one, as it toggles from true to false, the outcome toggles from true to false, rest are held constant. And similarly, the last one, as it toggles from true to false, the outcome toggles from true to false. Now, we need all this. Out of the 32 rows, we need 1, 2, 3, 4, 5, 6. We need 6 test cases for achieving MC/DC coverage, and we have 5 basic conditions and we need 6 test cases. Now, let us see how we can systematically create the MC/DC test cases. Let us take an example. We will, this is the example A and B. A and B are Boolean variables, and we need to create the truth table of course, but then we will create a extended truth table. In the extended truth table, for each basic condition, we will keep a note of which 2 rows independently influence the output for a specific basic condition. Let us first see how to have the extended truth table. We have the truth table here, we numbered the rows 1, 2, 3, 4. There are only 2 basic conditions. So, we have 4 rows in the truth table, and this is the outcome, and then we just check here that when A is true and B is true, the outcome is true. Now, if A is false and the B is remaining true, the outcome is false. So, 1 along with 3 will show the independent influence of this condition, first condition, on the outcome. And as we go around, as we go check all the possible rows, of course, we will find 3 along with 1 also independently influences the outcome, and the other combinations are not able to independently influence the outcome, but for larger sub expressions and other examples, we will see that there may be several pairs of rows which independently show the independent influence of the first condition on the outcome. Similarly, we check the second condition. We see that when A is true and B is true, the outcome is true. And in the next one, we say that A is held true but as B becomes F, the outcome toggles, and therefore, 1 along with 2 will show the independent influence of B on the outcome. Similarly, 2 with 1 will also show the independent evaluation. So, we can take either 1 3, okay, sorry, we have to take 1 3, tests 1 3 for independent influence of A on the output, and 1 2 for the independent influence of B on the output. And our MC/DC test suite will be the first row, second row and third row. So, we had, so this is the MC/DC test suite. So, we had 2 basic conditions and we need 3 test cases. Okay, the test suite is 1, 2 and 3. Now, let us look at another example. This is slightly larger example, 3 Boolean variables A, B and C, and therefore, we need 2 to the power 3 rows in the truth table. We have drawn the truth table here, extended truth table, where not only we have drawn the truth table, but also we are keeping note of which rows result in independent influence of A on the outcome, independent influence of B on the outcome, independent influence of C on the outcome, and then we will identify the MC/DC test suite. So, this is the extended table. Now, let us take the first Boolean variable A. Now, as we scan through here, A is 1, when B is C and held at 1, result is 1. Now, let us see where B, C are held at 1 here, but then this does not help. A has toggled, but the outcome has not toggled. So, that does not help us. Now, let us check the second one. When A is 1, B, C is 1 0, outcome is 0. Now, let us check where 1 0. So, this also does not help us. Now, let us check the third one. So, A is 1, B, C are held at 0 1, outcome is 1. Now, see, let us see where it is 0 1. Okay. So, A has toggled from 1 to 0 and B, C are remaining 0 and the outcome has toggled, and therefore, we select these two. These two show the independent influence of A on the outcome. Similarly, if we scan through for B, we will find that 4 and 7 that show the independent influence of B on the outcome of the expression evaluation. Similarly, for C, if we scan through the truth table, we will see that 1 and 2 will show independent influence of C on the outcome. Just see here, C has toggled from 1 to 0, outcome has toggled from 1 to 0, the rest are A, B are held at 1 1. So, these two will do. Now, let us create the MC/DC test suite. We need 1 that will show 1 and 2, that will show the independent influence of C. We need 3 4 and we need 7. So, that is 1 2 3 4 5. So, that is 5 test cases. Okay. So, it is linear in the number of test suit, even though it is not n plus 1, because here that does not hold, but it will be around that. Now, let us see when there are multiple rows can show the independent influence of a variable, we will have alternate possibilities for the MC/DC test suit, and we need to select the minimal test suit in that case. Let us look at this expression A, B, C. Okay, there are 3 A, B, C are the Boolean variables, and there are 2 to the power 3 is 8 rows in the truth table, and we have written the truth table here. We see here that 1 along with 5 shows the independent influence of A on the outcome. Similarly, 2 along with 6 also shows the independent influence of the basic condition A on the outcome. Similarly, 3 along with 7 also shows the independent influence of A on the outcome, and naturally we will have 5 and 1, 6 and 2 and 7 and 3. Just the same thing here, because this is 1 5, 2 6 and 3 7, we have 5 1, 6 2, 7 3. So, this of course, can be easily found out based on this. Now, let us see the independent influence of B on the outcome. We have 2 4 and of course, 4 2. Similarly, for C it is 3 4 and 4 3. Now, when we choose the MC/DC test suit, we can find that 2, 3, 4 and 6. So, 2 6, 4 3 and 4 2. This has to be included anyway. 4 3 and 4 2 will be there, and we can either choose 2 and 6 or 5 and 1, etc. So, if we select 2 and 6 for the A, then we have these 2 possibilities, 2 3 4 6 and 2 3 4 7, and also there is a non-minimal set where we include 2 4 2 and 3 4, 4 2 and 3 4, that has to be there, 4 2 and 3 4, and also we include 1 5. So, this is a non-minimal set requiring 5 test cases, but here we can have the minimal set, which is 4 test cases. Now, let us note down our observation. MC/DC criterion ensures condition decision coverage, and also it shows the independent influence of every basic condition on the outcome. The number of test cases is linear in the number of basic conditions. Typically, for n basic condition, we need n plus 1 test cases. Of course, sometimes we have non-minimal test cases where we need 1 more, but this is a very strong testing. It subsumes the condition decision coverage, which in turn subsumes decision coverage and which subsumes statement coverage. Of course, MC/DC is subsumed by MCC, but MCC is impractical. So, MC/DC is a strong enough test criterion and also requires small number of test cases, and therefore, it is very popular. So, MCDC, just to summarize, we require basic condition coverage, branch coverage, and also we show that every condition independently affects the decision's output. It is subsumed by MCC and subsumes all other criteria and is stronger than statement and branch coverage. It is a good balance of thoroughness and test size. It is widely used. Here is just a small assignment for you. Just noted down a simple branch condition having 3 basic conditions, and please develop the MCDC test suite. You can of course frame further branch conditions on your own involving 3, 4, 5 basic conditions, develop the truth table and decide on the MCDC test suite. Now, let us look at path testing. Path testing is based on the control flow. The main idea here is that we need to design test cases such that all linearly independent paths are executed at least once. So, we need to define this term, what we mean linearly independent paths. And as I was mentioning, the paths in a program are defined in terms of the control flow graph of a program. So, we need to first discuss how to draw the control flow graph of a program or the CFG of the program, and once we are able to draw the control flow graph of a program, we will see what are the linearly independent paths and how to estimate the number of linearly independent paths in a program, and that will tell us about the number of test cases required to achieve path coverage. The most basic question here is that what exactly is the control flow graph? What does it indicate? The control flow graph indicates how the control flows through the program, which in turn is the sequence in which the different instructions of the program get executed when a test case is executed. Now, the next question is how to draw the control flow graph. The first step, given a unit or a function, the first step is to number all the statements. We can develop the control flow graph either for a segment of a unit or the full unit. We have not numbered the first statement here, because anyway that will get executed, and the rest ones we have numbered here 1, 2, 3, 4, 5, 6, and these numbered statements become nodes in the flow graph. Now, we draw the edges between the nodes. So, these we draw the nodes here 1, 2, 3, 4, 5, 6, and the next work is to draw the edges between these nodes. We draw an edge from one node to another when we see that execution of the statement representing the node can transfer control to the other node. Now, let us look at this case. We have 1 is the while statement From here it can enter the loop, the control can come to the next statement. So, 1 to 2 it can come, and also if while becomes false, the control might come to 6. So, drawn here 1 to 6. 2 is a decision statement, and from 2 either the control can come to 3 or it can come to 4. So, that is what I have represented. So, that is the basic idea here, that given a program segment or a unit, we first number the statements here, and then these become the nodes on the control flow graph representing each statement, and then we draw an edge between the nodes if in the program control can flow from one node to the other. So, the same example here, that we have numbered the statements and then we have drawn the corresponding control flow graph. But let us look at a systematic way how we can develop the control flow graph for any given program. To draw the control flow graph for any given program, we need to understand that every structured program consists of 3 types of statements: sequence, selection and iteration. And if we can understand how the control transfers for these 3 types of statements, then on the control flow diagram we can represent those edges. Whenever we find a sequence type of statement in a program and we know how to represent sequence which is, then we can easily draw that edge. For selection, if we know how to draw the edges, we will do the same thing on the control flow graph, and for the iteration. So, these are the basic 3 constructs. Let us understand how to draw the edges on the CFG corresponding to these 3 types of statements, and then given any program we should be able to easily develop the control flow graph, because they will after all be consisting of these type of statements. We are almost at the end of this lecture. We will stop here and we will continue in the next lecture from this point.